Okay, this is, we're in chapter 4, and today we're going to be discussing lesson 4B, which is all about interest. And so the principal is the balance on which the interest is paid. We're going to work several example problems where we're going to kind of drill down these definitions, but the interest is the money paid regularly at a particular rate for the use of the money lent or for delaying the repayment of a debt. If you're calculating simple interest, you're gonna only calculate interest on the original amount and not on any interest added after that. Compound interest, you're going to pay interest on the original investment and all interest that has been added to the original investment. APR is the annual percentage rate. This is the annual rate charged for borrowing or earned through an investment. It's expressed as a percentage. It's the actual yearly cost of funds over the term loan. Okay, and when we're talking about simple interest, we've got the definition above, but there's a formula that we're going to use, and the formula is A is equal to P times I times N plus P. Okay, A represents the accumulated balance. P is our starting principal. I is our interest. N is the number of periods, which means how many times did it happen? Okay, and we've already talked about P as the starting principal. To calculate compound interest, we're going to have A is equal to P times 1 times the APR over N. And then we're going to raise this to a power of N times Y. Okay, so A again is the accumulated balance. P represents the principal. And we've talked about what APR is. It's the annual percentage rate. This little n is the number of times, or the number of compounds per year. Okay, and the y at the top is going to be the number of compound periods. Okay. So I think the best way to kind of delve into this is to work some example problems. So our first problem says you have $5,000 and you're trying to decide where to invest your money. U.S. Bank pays an APR of 3% and it compounds interest monthly. Arvis Bank pays a general APR of 13.5%, and Heartland Bank pays 4.5% compounded quarterly. Arlington Bank pays a simple interest of 2% compounded bi-monthly. Which bank is the best investment over a period of 5 years? So we've got 4 banks to talk about. Okay, the first bank was U.S. Bank. And at U.S. Bank, there's a 3% APR, and it is compounded monthly. Okay, second bank is Arvest, and at Arvest, it's just a 13.5% APR. not compounded at all, so simple interest. Heartland Bank was a 4.5% APR, and it's compounded quarterly. And then the fourth bank was Arlington, and Arlington Bank said that they would do a 2% APR, and that it's compounded bi-monthly. Okay, so let's do these calculations real quick. I'm going to go ahead and kind of scroll down a little bit. Remember that we had two formulas. The formula that we had was simple interest, and we had a formula for compound interest. And I'm just going to jot these down really quick. Okay, so let's just start. Our bank one, right? Our bank one is U.S. Bank. And they're if it has the word compounded, we're going to use this formula because it says they're compounded monthly. So the first thing we want to know is we're trying to figure out, well, how much money are we going to have after 5 years, okay? And remember that the problem said that we were putting in $50,000 to begin with. So A is going to be, our accumulated balance is going to, we're starting out with $5,000. I'm using this formula. So then I'm going to multiply that. And I'm not going to put this time sign because it kind of looks like an X. So I'm just going to write parentheses 1. And I have a mistake in this formula right here. This needs to be, sorry about that. This needs to be a plus. So let's go back. Let me change that 1 right above. Okay. So 1 plus the APR, and they told us that they had a APR of 3%. You're going to write that as a decimal. So you would do 3 divided by 100 to get percent to decimal, which is 0.03 over N. And N is the number of times this happens per year, and it's compounded monthly. So there are 12 months in a year, so it would be over 12. And then it says raised to the N times Y power. Well, N is 12 because there's 12 months in a year. And Y is going to be the number of years that it happens. So if you type this in the calculator exactly like this, right, you're going to get the right answer. Some of you may need to break it down and do order of operations if you don't have a TI-84. But you can go straight to $5,808.08. I'm also going to put a video on here, if you look under the calculator section, about how to type this in the TI-84 calculator. So bank number 2 is Arvis Bank, and Arvis Bank is they're just charging a simple interest, so we're going to use this formula. So A is going to be our principal times our interest of 13.5%. Remember, we need to change that to a decimal. So it's going to be 0.135 because we're going to say 13.5 divided by 100 to change it to a decimal. Okay, so the next thing in the formula is n. How many times does it occur? Okay, well, it's going to occur yearly because it's just simple interest. And then it says to add back on your principal, which is $5,000, and that's going to give us $8,375. Okay, the third bank, which was Heartland, once again, I see the word compounded, so we're starting out with 5,000. We're going to use the compounded formula times 1 plus the APR. Well, we need to do 4.5 times 100, divided by 100 to change that to a decimal of 0.045. How many n is how many times it happens per year. If it's compounded quarterly, there's 4 quarters in a year. Okay, then it's raised to the n, so 4 quarters in a year times however many times it's going to happen, which is yearly, so times 5. Okay, when you calculate that, that's going to be $6,253.75. The fourth bank is Arlington Bank, and they're also compounded, but only bi-monthly, so twice a year. So 1 plus 2%, 2 divided by 100 is 0.02. Compounded bi-monthly, so the n means it's going to happen twice a year. And then twice a year times however many it's going to happen, so times 5. And that comes up as $5,525.62. Okay. So there's a lot of things. It looks like this simple interest is crazy, right? Because the price is so much bigger. But it happens to be a huge interest rate, higher than any of the others. That's not normal. Usually if it's simple interest, it wouldn't be that high. Simple interest is usually the smartest if somebody will offer you a good interest rate. Okay, so it looks like the one that if we're going to invest our money, we would want to go with this one. So the bank we want to go with is Arvis because it's going to give us the most money. If you kind of compare the others, if you look at this one, 3%, this one was 2%, this one was 4.5%, and you can see how the money goes up as the percentage goes up. So the 2% would be the least of the three, then it went to the 3%, and then the 4.5%. Okay, let's look at a few more problems. So the second problem says you deposit $1,000 into an account with an APR of 8%. Find the annual percentage yield with monthly compounding and with daily compounding. So we're doing two different problems. So first thing we're going to do is figure out how much we've accumulated. And so it's using the word compounded. So I know that since we're using the word compounded, I'm going to want to use the compounded formula. So the first time, let's do the monthly compounded first. So this one's going to be the monthly one. We're going to start out with $1,000, and then we've got 1, right? Our principal times 1 plus, it said our annual percentage rate was 8%, so 8 divided by 100 would be 0.08 as a decimal. And if it's compounded monthly, the n here is going to be 12. And then 12 times however many times it happens. And this is just happening one time. So we're going to multiply that 12 times 1. I'm going to use a dot instead of a times symbol just because of the algebra that we'll be doing. Okay, and so that's going to give me $1,083. And to calculate the annual percent yield, we're going to take what we earned, right? So what's the difference between 1,083? So 1,083 minus 1,000, well, we earned $83 in a year, divided by what we put in, divided by our principal that we put in, which is 0.083. And if we multiply that by 100, 0.083 times 100, we can write that as a percentage of 8.3%, and that would be compounded monthly. So the next one says, well, what do you get if you compound this thing daily? So if we compound it daily, we're using the same formula as above. So we're still starting out, our principal is still going to be $1,000. But our APR is still going to be 8%. But our number of times it occurs now is gone up to 365 because there's 365 days in a year. So this is in, this is also in the number of times, and we're only doing this for 1 year. Okay, and so that's going to get me $1,083.28. Not way off from what we had before. If you take 1,083.28 minus 1,000, you're going to get $83.28. And so my annual percentage yield is going to be $83.28 divided by what I put in, and that's going to be 0.08328. If we multiply that by 100 to get our percentage of 8.32%. And in a year, that doesn't make a lot of difference, but over several years, that would make a huge impact. You deposit $1,000 into an account with an APR of 8% and continuous compounding. So now we've gone for, we're compounding continuously. This is going to be a different formula. I call it the PERT formula because it spells out PERT. Okay, so that, and we're going to compound it. So we're up here, we compound it every single day, but we could get even smaller than that. We could get to every second, every part of a second, okay, that we're compounding this interest. And so this is what this PERT form, when it says compounding continuously. So the P stands for our percent, the R is the rate, the T is the time. So if we put in $1,000, E is just a number like pi. And so we'll talk about, that's on your calculator. We'll talk, if you watch the how to do this on the calculator video, we'll go over where these buttons are on the TI-84. But we've also got our rate, which is 0.08. 8 divided by 100 would get you 0.08 times 10. If we calculate that, that's $2,225.54. Now that was for 10 years, okay, which is this up here we just did for 1 year. So that's a big difference. We've more than doubled our money, our $1,000 that we put in, if we compounded it continuously over 10 years without doing anything else, without adding any other money. Okay. You just had your first child and you decide to invest money into an account for their college education. You think your best option is Arkansas Bank that gives an interest rate of an APR 3% compounded monthly. How much will you need to deposit now in order for you to have for your child to have $100,000 for college education? So you're not going to put anything else in. This is compounded interest, so we would use the formula A equals P times 1 plus the APR Okay, so they told you that you need to have, this is what the answer needs to be, $100,000. And they're asking you, well, the principal, what would you put in to get that? Okay, so this part would be 1 plus 0.03 over 12, and 0.03 came from the 3%. 3 divided by 100 was 0.03. That says we're compounding this monthly, so that's 12 times a year. And usually it is about 18 years before a child goes to college, so we're going to do this for 18 years. If you're going to work this problem, the first thing you're going to need to do is you're going to need to kind of consolidate all this stuff. Okay, so you could do several steps here. I went ahead and figured out just the part in the parentheses, so that would be 1.0025 if you do 1 plus 0.03 over 12. Got to make sure you type it in exactly like that or you're not going to get it. Then I went ahead and said 12 times 18 is 216 and got that finished. So then I've got 100,000 is equal to P, and I went ahead and figured out, actually we could just leave it like this. So if I divide both sides by 1.0025 over 216, this is going to cancel with this. Okay, and my answer would be 100,000 divided by 1.025 to the 216th power, which is going to get me $58,314.11. So it's roughly going to, I mean, it's getting close to doubling, but I'm going to have this much money on the front end if I don't plan on putting anything else in for him or her to have $100,000 by the time they graduate. That was the end of section 4B. Make sure that you go back and watch that calculator video, practice on your calculator, because that's going to be one of the hardest parts of doing this section.